Hello, in this problem, a 10 kilogram explosive device is floating through space in the positive x direction at 100 meters per second. It explodes into three masses. We have mass 1 with a mass of 2 kilograms, a velocity of 30 meters per second. We have mass 2, which is 2 kilograms, and it has a velocity of 25 meters per second. And we have mass 3, which is 6 kilograms with a velocity that is unknown and an angle that is unknown. We also have mass 1 going at an angle of 60 degrees and mass 2 going at an angle of 45 degrees. So what we want to use here is the conservation of linear momentum, and it states that the total momentum of the system is preserved, and note also that there are no other outside forces acting on the system. So we have to use the fact that the vector momentum of the explosive device is going to be equal to each vector momentum of each mass immediately after the explosion. So here I chose the coordinate system for the positive x being to the right of the movement of the particles, the positive y to be going up, and negative y to be going down. So what we have to do is use that equation for conservation of momentum, and we're going to use that to find the x and y components of what is going on for the entire system at the instant of explosion. For the x component, we have 10 kilograms, which is mass initial, times 100 meters per second, which is the initial velocity. And we're going to set that equal to m1 v1 in the x plus m2 v2 in the x, and m3 times v3, which is going to be our unknown. And that's going to be the x component of the velocity of the third mass. And here I used the negative 60 degrees since this is going down and this one's going down in the negative y also. So I use negative 60 and negative 45, but also note that cosine of a negative angle is just going to be cosine of the angle. But that's not going to work the same for the sine of the angle. So for the y component, we have 10 kilograms times 0 meters per second. And that's because this is moving linearly, so it's going to move only in the x, in the positive x. So since there's no motion in the y direction, it's just going to be 0 for the velocity of the y initially. So we're going to set that equal to the momentum in the y. So for mass 1, we're going to have a momentum of 2 kilograms times 30 sine of minus 60. For mass 2, we're going to have a momentum of 2 kilograms times sine of minus 45 degrees, and this right here is actually a typo. So next we're going to have momentum in the third particle. It's going to be 6 kilograms times v3 sine theta, and that's another one of our unknowns. So overall, what we're going to do is solve in each case for v3 cos theta, and in the y component, we're going to solve for v3 sine theta. So that's going to give us our v3j hat, for example, in the y, or our v3i hat, for example, in the x. And all we have to do is basically use the Pythagorean theorem once we have each value, and we're going to solve for the magnitude of that third velocity. So doing that, I got 156.5 meters per second. And to find the direction, I did tan inverse of v3 in the j over v3 in the I, and that gave me an overall direction of 5.8 3 degrees, and that is it. Thank you very much.